So, you've seen this before. Today we're going to do a little review. This has been up before, so this shouldn't be a big surprise. We're going to talk a little bit about the lab, talk about what's coming up next week. I'm going to do some problems with you on gases 4 and an extra problem or so, and then we'll see where we're at. A couple other big announcements with that, though. So, first, I want to talk about those. Next week, so we have a test this Thursday. Friday, we were just doing an introduction, very light, because I'm not going to be here for tennis. Found out all I do is new incognito window, and I just paste the address of the voting, and I have Mr. Smarava on it. He's at about 100 votes already, so ba-boom. We just keep voting for the tennis team. But that being said, first, please know that your lab, I sent you an email about this, that on the website itself, and the red things from recording, some people aren't here today because of PSAT, but you have your post lab on the 3rd page. So it is really important that you're understanding that you need to figure out these 3 molar masses before you can actually identify which one your compound was. We'll get there and talk about that in a second. The other thing I want to talk about is that just because you're an AP does not mean that you still also can't have the fun that the peons are able to have. Oh boy. Look it up. So, it was a joke, but you don't know the word doesn't really help. On Sunday, besides the fact that, what is Sunday? Well, it's actually 2 things. It's now the greatest day of the year. It's also Walking Dead premiere.
Oh, yeah.
Yellow. Yeah, I know. But actually, that's not during Mole Day anymore because Mole Day would have ended at 6:02 p.m. So really, we're not really mixing things up. But on Monday, we are still doing the Molympics. Yes, you still get to have fun. And yes, yes.
Remember my container last year with the big truck with 10 wheels?
Yes. Yes, I do. I remember all of these, and you get to do it again. And I'm glad that we're excited because every year there's always an AP person. I kid you not, they're like, I'm in AP now. I don't do those kinds of things any longer. Like, are you kidding me? Like, wow. Like, we're not going to get along very well. So, on the webpage, on the right is Molympics. You click it. It's the same as last year. You still have an assignment. Yes, you have an assignment. You have to create a mole. Okay? Now, you can cut it out, and this is generic if you want, or you can create it. Like, this was spaghetti and mole balls. This was Walter White from Breaking Bad. And he had money and, the money! And so on and so forth. Moldy cheese. Molios, as you can see. Okay, so you got to create one. If you don't want to put a lot of time into it, that's fine, but you got to create something that's worth points, and then you got to color a mole. So I want you to understand how this works. It clicks down here. I cannot change this. These are thumbnails, my favorite one, guacamole. If you print it from this, you will only have about 1/3 of the page. Do not print it from that. This is a sneak peek. You move up here and you click guacamole, and voila, you get the entire page. Well, what am I coloring, Mr. Gussie? What do I do? There are categories. Most Wisconsin, toughest, cutest, and best overall coloring. So if you're just coloring and be like, I'm just doing a really good job here, well, then you may be best overall. Maybe you're trying to make it cute. You can add things. You can remove stuff. Make it really tough. And by just putting slants down above their eyes does not make it really tough. Okay, you gotta do a little more than that. Although I know that is mean then. And then with a smile even more, then it's like they're up to something. Or just most Wisconsin. There is a new one that was the theme from last year, is Mole Wars, May the Moles Be With You. I will have that online too, and you can color that. Unfortunately, there's just some of it all black, and that's not as much fun, but they're all moles. My favorite one's the, oh, come on. I think it's hard to see, but that's Chewbacca, or Molebaka. He's all furry, but it's hard to see. So, anyway, if that's your cup of tea, that's fine. But that is for Monday. Although Halloween is the following Monday, we will be doing Chemistween next Wednesday. Yes. Now, please understand that it's mostly the same. It's hard to come up with new stuff. We don't want Mr. Neubauer to get hurt. Those that don't know, he almost blew his fingers all last year. He did. He actually really, all joking aside, he really did like second-degree burns on his hand. But I need help. So you have a chance for extra credit if you'd like. This box. Last hour I had a real hard time understanding this concept. This is a box that you can put your name in. And on Monday, at the end of Monday, I will pull out a certain number of names. I don't know how many yet, 4 or 6, let's say. If you're putting your name in there, you're saying that I am available, meaning you, not me, for roughly 2 hours or an hour and a half at least on Tuesday evening. If you're like, well, I can, but I can only do it for 15 minutes. Don't put your name in there. I'm going to be very upset if all of a sudden I pull your name out and then I find out you walk by like, hey, I can't. Obviously, if some emergency came up, that's one thing. But you are, by putting your name in there, you're saying that, yes, I am available. You get extra credit. Is it fair or not? I can't have 30 kids in here setting it up, but I do need help. And usually people have a really fun time. It's only been bad once with people helping. I bought a new skeleton, and 2 guys thought it would be funny to violently unplug all, it was plastic, unplug all the legs and arms, and they made foot hands and then made hand feet, and unfortunately they like ripped all the plastic. I actually found an assignment and made it a 0. They lost points from helping because they destroyed, it was new, it had never been used, they destroyed $25 worth of a skeleton, so I was pretty upset about it. If you were there, you'd be like, what are they, I mean, it was sword fighting with the femurs, and it was just a mess. So, if you want to help, and you're into that, you want to do it, great. We will be, unfortunately, the way we're setting it up and why we're not doing it on Monday is that during fall break, you didn't realize it, fall break is Thursday and Friday next week. We can't have this room set up for the entire, like, 5-day weekend. It's going to all fall down, and there's some fire hazards with that. And because of Wednesday, and Mr. Neubauer, Mr. Blackford, and I all have large group chemistry, so I can actually get some more help throughout the day at the same time instead of like in and out. But you guys, meaning translation, you guys will not have anybody else in here but you for that day. So it'll be a little weird because there won't be that many, but I work by applause and energy, so hopefully we'll have a lot of that. We'll have fun. So the only thing you gotta do on for the week for chemistry is just Tuesday. We'll have a little bit of something with our new chapter. Any questions about Olympics or Chemist Tween? Yes, sir.
So the requirements are 2 drawings and 1 of those.
And want to create a mold, yes. And it, to be very upfront, if you don't want to put in a lot of time, but I need participation at least, that's fine. But if you put in a lot of time, you can add points to your team and everything else. And some people actually have fun with it. So.
Wait, so 2 pictures?
Yes.
When you said set up after school, is that like right after school?
It's roughly like 3 to 5 or 3. Usually we're done early, like 3 to 4:40 or something like that. Yeah. So I mean, if people have practices or other things too, I totally get it. But if it works in your schedule, great. Anything else? Okay. Let's talk about the lab. So, lab. This is what we're working with, okay? So we need to be able to figure out these variables. Now, Morgan, I know we talked, but I talked to a couple other people and they actually had really good numbers. So what we need to do is maybe compare with, like, what one number is like jumping out from theirs to yours that doesn't seem the right size, okay? I think that's the good first start.
What was the weird one what was the one that she was?
I don't know. It was her final answer.
Oh.
Okay, so what I showed you at the ending, there's that post lab. You have to figure out, is this methanol, ethanol, or acetone? Okay, so I'm just going to throw this out here first because I don't know where we're all at. Anybody having any issues with determining any one of these? And if you haven't started it yet, that's always a problem. You always want to try to start things so then if you have questions, you can ask that before it's due, not the day of it being due. You want to be feeling good coming into class when it's due. It's due tomorrow. By the way, I'm going to throw out a little word here called bookwork.
What's that do tomorrow?
That's why I'm throwing it out there. The point is that you're supposed to be doing the problems as they're assigned. Hypothetically, you would have done 3 on 10-7 and 3 on 10-10 and 2 on Wednesday. And actually, that would have been it. So you should have actually been done last Wednesday. I have a feeling some of you will start this evening. So just FYI, that's there. All right, questions on this though? I have been seeing some issues with the volume. If you are confused by that, on the website, right here is the reference. That's your density. So you had to take a temperature. Let's say it's 19.998408 grams per milliliter. What does that mean? Well, you had mass of water. What do I know about a T-chart? What has to happen next, no matter what, even if I don't know what I'm doing at all? What's the next truth of this? What's a fact that I have to do? Grams on the bottom, right? So what does that mean for any one of these numbers? What does that mean? How do I do this? Because what we do is we get so rigid in our applications of things that we don't actually think all the time and think about what this actually means. When I say 0.999, let's just leave it at that for right now, grams per milliliter, 0.999 grams per milliliter, how do I apply it there? Anybody? Yeah, Nick?
So we put the 0.99 on top of that, and then you put 1 milliliter, so 0.1.
Okay, so you're saying it's like that? Okay, so how can I apply that to this? Okay? Okay? And what's the difference? It's like saying 1 mole equals 32 grams for O2. 1 mole equals 32 grams. Why can't 32 grams equal 1 mole? They can equal each other. So exactly, we are going to be putting that in density. Please use all the digits though. This is a very precise measurement that's already been done for you. So this would be 1 milliliter. And then you do one more step and you get in your liters. Your final volume, I mean, it was an Erlenmeyer flask. This is my Erlenmeyer sun drop. It was 125 milliliters. The 125 goes about here. So if you're getting like something like, I have a 2-liter container, it doesn't make a lot of sense. Like, it shouldn't be much, it should be less than 200 milliliters. I think like 150-ish. So, does anybody have any questions though about, that is where I'm worried about right now. Like, where do you get all this from? If you can't get that, then we can't identify anything. Do my wait time, my head, 4, 8. Okay. So, do find me. I am lecturing in large group though today, so it's going to be a little tricky to ask me questions, but always throw me an email if you need anything. But answer for the post labs online. Okay, so please utilize that as you're doing that. I'd say your paper. Okay, let's talk some business. Guesses? 4. Last night we had a review. Thank you for those that came again. I had a crazy night. So I had a review. I had to go home because I had all new windows in my house just done to meet a guy. I get there, call him, he goes, oh, I'm not coming. And I live in Green Bay. So I had to drive all the way back. And then I had an ACT prep class for 45 minutes. And then I had to drive back to go get my son for a Cub Scout meeting. Then I had to drive him there, which was only supposed to be an hour, which ended up being over almost 2 hours. I get home, I start eating my supper at 9, and my favorite baseball team's the Cubs, and they're getting their butts kicked. And I finally sat down, and then I had to create a lecture for an hour and a half for Kevin. It was just like, this is not my favorite evening of my year so far. It was just crazy. But it was a really good review. If you did not get a sheet, these are pre-made from actually your textbook. Like, they're not all necessarily going to be on test questions. I want to be very clear about that. It's not like, oh my God, I need to know every single thing on here. You have to understand that we tailor this class to what we need to know. And you should have a pretty good idea of what things, if it jumps up, you're like, I've never seen that before. And it's probably not there. Like we go over things pretty well, I feel, and keep things pretty straight of what are we responsible for, what we aren't. But the answers are on there. If you did not come last night, I'd suggest taking a packet, even if you just want to watch the beginning of the video, or just, okay, you're doing number 10, or you're doing number 44. And I do all the work, and you can kind of see how it's done, and that's online already. Between that one free response question, and all the other work we've been doing, I feel like we're pretty much ready for our test. Of all tests, I do not want to pull your guard down, but usually people do really well on this test. because I told you I moved this test this time because of tennis. I'm in and out so much. But I do have students just fall flat because they just act like, well, I'm good to go, and they just come in like, oh my gosh, I didn't know that I needed to know PD equals NRD. It's like you got to know what you need to know.
Are these problems from the AP Chem book?
They're from your actual textbook, but not in the textbook. Like it's an extra book that.
Okay, so these numbers aren't like the book.
No. They're separate. Yeah. You're like, did you do the 8? No, they're not. They're not exactly the same. So, open it up first on the front, 1 through 8. Anybody have any questions? I'm going to be doing a few. So, Maddie?
Can you do 6?
Sure. I hope I can. Okay. So it says that 24 grams of nitrogen gas and 12 grams of hydrogen gas are mixed and ignited. How many liters of ammonia can be formed at 25 degrees and 1.2 atm pressure? Good question to ask. Not that this was a good question. What do I always need? If I start talking about different compounds, what do I need? I need the equation. This is chemistry. That's our story. So I'm going to let you figure out an equation later, but I'm going to write this one down. This is the Born-Haber cycle. This is a famous equation. And it's very useful because we have 3 different coefficients. Okay? So, the reason why I knew I needed an equation is because it listed different compounds, and then at the ending it's asking an actual question word of how much something else is created. Okay? So, I have 24 grams of this. I have 12 grams of that. And I want to know volume of this, and then it gave me some conditions. Okay? So this looks like a little strike. Okay? What is this telling me right here? What type of problem is this? A stoichiometry problem. It's a limiting reactant. So I need moles. Okay? I'm going to need moles. So if I'm thinking about my flow chart, all right, I'm starting in grams, right, up here. I want to get the volume down here. Can I stay on the flow chart the whole way? No, I need to take a detour right there because I'm not at STP. Obviously, we used to have a lot more written on here, but you need to be able to just visually see where all this stuff is at. So, simply put, you need to show this stuff. And I'm going to do this kind of quickly here. Sorry, getting a little sloppy here. What is this? A little less than 1. Point what? Anybody? Can I do this yet? No. Okay, yeah. 0.857. Right. I don't mean to pack it in this tightly. It's just we're almost out of room. Do I need to do math to show what the limiting reactant is? I need 3 times this amount. I have over 6 times that amount. That is in excess. Clearly, I don't have enough of that. Right? Just it's very small. I would never say clearly if it's not that clear. Like this is just, it's not even close. I am running out of the H2. So I am going to go forward. And maybe I could have just kept going with this. I just don't have room here. Let me do it. Let's do this. So you could have even figured that out. Either you have that number, or I could just do this as well and just keep going. And now, what do I have? 1. All right. So we'll shrink that up a little bit. So I'm going to get that answer. And now, I think this is important just for you to understand. You want to make sure you don't lose any points. I'm at moles, right? I went from grams to moles, and now I need to do an ideal gas law. I'm solving for volume. This is what I'm hoping I'm going to see from you. That you do a subscript. Hey, I'm solving for volume of ammonia. So it's V sub NH3. I think it's a good idea. It's not required to plug in all your variables. So nRT over P, and then I'm going to plug them in. And I'm going to leave you at that, because I think you can make it from there. Okay? because we're going to do one actually at the end. Yeah, great.
The chart isn't supposed to be N2.
Yes. Yeah. Oh boy. Yes. So wait. Good call. See, that's what happens when you cram things in. Nice call. So that can't be right then. Nice move. It's just getting worse. Very important for labels. What did I just erase? A 3? There you go. So that's my mole. Sorry about that. That's why units are really important. Really important. I'm not acting like I didn't make a huge mistake. That would have been a big mistake. Make sure that you are, on the test you will have plenty of space for this. Just writing with this marker, I crammed it in. Also, the next thing you know, I can't see what I'm doing. Good job. Or what else? Yeah.
Do the backside and we'll get
Yeah, we're going to do the whole backside together in a minute.
oh, alright.
Like literally, like that's one of my big plans today. Yep.
And oxygen molecule, what's the molar mass?
What is the molar mass of that? What would you say if you had to commit?
I think it would be 16.
Okay. 16 would be oxygen. What do we know about oxygen molecules when they're by themselves?
Oh, that's right.
You have to know, unfortunately, right? So halogens, okay? There's 7 of them that just, you have to recognize, oh, it's by itself, it's always going to be ocean. Okay. Okay. We are going to flip to the back. And if you've done this, I'm sorry, then you check your work. This was on last year's test. And I've had it on and off of tests. So I just want to let you know, like, these are test worthy. Like, I've had this. And as an actual test question. So we're going to take our time. I'm going to have you work either by yourself or with someone else. If you've already done it all, then confer with them what they have after we have this time. So a couple things I just want to speak on once we get through this. So, okay, you got an image, so we're comparing this. Remember, if it's ever written up here, it applies to the entire situation potentially. Okay? So it's important to understand how it's laid out. Consider 2 containers of volume 1 liter at 298 Kelvin as shown above. One container holds 0.1 moles of N2, the other holds 0.1 moles of H2. The kinetic energy of N2 is 6.2 times 10 to the negative 21st joules. Assume that they both exhibit ideal behavior. Ideal behavior just means that they literally don't interact with each other at all. A, is the pressure in the container holding the H2 less than, greater than, or equal to the pressure in the container holding N2? Justify your answer. Okay, before, I don't want answers yet. I want to talk about the things that I read and how you're supposed to respond to this. When they say these words, you need to say those words. Okay? When they ask it in H2 versus N2, you need to do it in that point of view. So what I'm hoping for, I don't know if this is the answer. Well, I know what the answer is, but I'm not saying this is the answer. If you say H2 is less than, well, you have to say H2. Let's just say you think it's greater than. I would love to see it literally written greater than. I would love for you to underline the word that they want you to say, and then you say because, or you say the reason. What I don't want to see, and this is what I get all the time, you start rambling. Brevity is beautiful. 1 to 2 sentences tops. H2 has similar pressures and temperatures, and because of the temperature is the same, that would create a equality between the temperatures, which would then create volume, which would also be the same. Therefore, I believe, with my most educated guess, that I'm going to go with, and then my favorite part is, N2 is greater than H2. Ah! It's about that one in terms of that one. I cannot tell you how many times people will go, N2 is less than H2. We're like, you just made me have to think even more. And I'm upset about it. I need you to understand, it's human nature. I'm not saying they do this, but if your answer is borderline correct or incorrect in May, and they're scoring this, and they have 180,000 that they're scoring, and you pull something like that, and there might be something wrong, they might just be like, no, I don't like this. Or you have this really long paragraph, and you're just writing and writing and writing and writing, and then you just squeak in, Like last sentence, the last word. And that's because, and therefore it's equal. Like, you made them read all of that. Like, I read things from year to year where I have no idea which way you're going, and then at the last second, like, literally you contradict yourself like 8 times. So I'm like, this student has no idea what they're doing. And then all of a sudden they're like, and therefore they are equal because, and then you have like the perfect answer right at the end. It's like, what, just cross all that off, and all I would need is like that much. So, please, start with the actual issue at hand. The H2 is what? Then N2, because, and then give the answer and get out of there, okay? So, let's talk about it. Is the pressure in the container holding H2 gas less than, greater than, or equal to the pressure holding N2? Justify your answer, and we want to shoot on this. Yeah, Evan.
I said pressure holding H is equal to the pressure holding N2 because they're the same moles, rate, temperature, volume.
So they're under the same conditions, basically. Now, I want to talk about something else. I'm not saying that this is I like your answer better. I just don't want to read it all. If you're having problems, like you finish an explanation, you're like, I feel like I said what I wanted to say, but I'm having a problem, or I don't have a lot of confidence with that. I do not want calculations. I do not want to see 2 P equals NRTs over V's. And be like, see? Like you do the math twice and be like, yo, there. Like you just put star and like you just drop your pencil. But you could say that they're same conditions and according to the following relationship, that would make it equal. You could say with the relationship of, and then you could actually put this out there. What I like, I'm giving fragments here. A picture says 1,000 words. So an equation does help with relationships. If you're having a hard time, it's getting a little cumbersome, your explanation's getting a little difficult for you because you're trying to explain a relationship, use an equation. But the equation's not there to do the math. The equation's there to kind of solidify your point. I don't know if that helps. It helps me a lot. If I remember, like, I feel like I'm 2/3 of the way there, if only I could have used the equation. You can. But you're not using it for math. You're using it to help show an idea. These are free response questions, okay? Again, AP is very different than general. We need to actually understand it. You're not a robot. It's like I'm just following orders. Like, you need to actually have an idea of what things mean. All right, B. What is the average kinetic energy of H2? So let me not ask that. Compare, don't cross yourself. Compare the average kinetic energy. If I asked you to do that, what would you say? They're the same. Okay. What is the kinetic energy of H2? Aha. They told it to you for N2. So if they're the same, 1/4 of the students, whenever I give this as a test question, get that right. But it's funny, the minute I didn't cross that out first hour, that's why I just did it. I didn't cross that out first hour. You should have heard the answers. I heard number 8. I heard an 8. I don't even see 8 in here. Well, like, they're, oh, wait a minute. There's an 8. Like, seriously, they're like, I heard 8s. I'm like, where? They're like, I don't know. I have no idea. But the minute I crossed it out, they're like, well, it'd be the same. Yeah, it would be. Temp, right? Temp. Temp changes. Obviously, you wouldn't be like, oh, well, clearly that's 3.7 times 10 to the, like, you wouldn't just know it. You'd have to have some information. What I'd like you to do, if you have it done or not, then confer with someone. I'd like you to work on C and D quickly. Hold on, one sentence. If you're like, I have no idea, I need you to try to write something. You got to commit. Give me an idea. Give me a thought. If it's wrong, if it's in pen, cross it out. If it's in pencil, we erase it. You got to try it. So, 1 minute. Get these 2 done. The point is not to be doing math.
Oh, okay.
If you did it, I get it.
Okay.
But just understand when that was created, there's certain parts on the test where you're not allowed to use a calculator. Like that was you don't
So then obviously you can't do it.
Right, so then,
Okay.
but using equations is great.
Okay.
So just know, like, if you see, like tomorrow when I'm gonna try to go on my way, like, this is the free response. Like,
Okay.
you are not doing calculation.
Yeah, I
I want ideas.
know.
Okay, molecules. Which one has the greater speed? And you have to justify, so you have to give a reasoning. It doesn't have to be like a great thought out sentence. It has to hit the main ideas. So we want to take a stab. Morgan, what do you think?
H2 molecules will have the greater average speed. H2 is the lighter gas, and lighter molecules travel faster.
Perfect. I want to change one word on you instead of lighter gas. Any word I want to put in there? Molar mass or lighter mass or lower mass. It'd be good to put the word mass in there though, okay? A great explanation though.
Like, I know we weren't supposed to do any math or equations, but I think the answer that you pointed out, does that like work to find out?
Say it again.
Like, with using the equations work to find out the speed of it, or is that wrong?
You mean a root mean square equation? What'd you call it? You call it PV equals T Pibner?
I don't actually.
Okay, we can still be friends, or whatever this is, I
just
guess.
say things though, but,
Okay, well, I will not call it that.
okay.
You can, but what you could do, so you're not, let's say you don't have a calculator,
Yeah.
what you could say, and due to this, and that's confirmed or illustrated with this equation or in this relationship. That's what you could say. Okay, let's pretend that we don't calculate, but I totally get what you're doing. Yeah, but I don't want to, like, the point of this isn't like I plug it in for H2 and I plug it in for N2 and then again I just go, see, look. Okay, but perfect, it is mass, right? So, right away, let me just get this really clear for you because almost every single time they do free response for gases, they will do a kinetic energy and they will do a velocity or a speed, okay? Or an effusion, and they're all the same. Speed, velocity, effusion, they're all talking about how fast it goes, and that's based on mass, okay? Kinetic energy is not that. Kinetic energy is based on temperature. That's the movement of the molecules. If it has, the movement's not just going forward. There's vibration. There's all sorts of different kinds of motion that occur as well, and that all deals with energy, okay? So just be aware. What change could be made that would decrease the average kinetic energy of the molecules in the container? And you got to be a little specific on this. But anybody want to take a stab at that? Eddie?
I said the change that could be made to decrease the average kinetic energy is a lower temperature. Kinetic energy goes up with temperature to create collisions within the container by decreasing the temperature of the surrounding condition.
And that is amazing. And all you have to write is that. That was amazing. But you just have to write lower temperature. The reason why, it doesn't say justify your answer or anything, okay? Be aware. That was great. It really was. But when it doesn't say justify or explain, I just want to let you know that all they're needing. Now, if you just said temperature, that's not good enough because it actually asks to decrease. So that's a shame. You're like, I wrote temp. Well, okay. Like, what do you have to do to it? You have to lower the temp. But if it does say explain, yes. And you wouldn't lose points. But that's great. That was perfect. Okay, what I'd like you to do, if you haven't done it already, I'm going to give you about another minute now. Let me read it first. It says, if the volume of the container holding the H2 was decreased to 0.5 liters, what would be the change in each of the following variables? In each case, justify your answer. Let me give you a little clue. AP questions, sometimes you answer them, and then when we go through them and I show you what they give you the points for, it's like, whoa, wait, I didn't know I had to show that, and like you lose a point. You're like, they never asked. So here's a little clue on something. You have to be specific if you can. The fact that they told you, they didn't just say they decreased the volume, they actually showed that I believe it was 1 liter, am I wrong? Was it 1 liter before? Okay, and I don't know if it's 2 zeros, it really doesn't matter, but now I gotta know. Let's be accurate. The fact that they show exactly the change, you might want to be, if you are able to, be specific. What do I mean by that? Like, does the pressure triple? Does it get cut in half? Like, what's actually happening? Not just it gets cut, it gets smaller. Like, how much smaller? You might, if you're able to figure that out, do so without a calculator. But if you need to use an equation, show it. But I want to know what happens to the pressure, what happens to the speed. Okay? So last two, I'm going to give you only about a minute because that's about all you would need to for the length of your answer. So Maddie, tone it down a little bit. Right, and then we're going to do just a couple other problems.
Actually, like an exact answer, so like, you're like, yeah, I know, right?
Grant, what happens to my pressure? It doubles. Did you use an equation to illustrate anything or not? What equation could I use? No, that one won't work. But think about this. I have a volume and a new volume. I start with a pressure. I want a new pressure. I have a volume and a new volume. I have a pressure and a new volume. This is Boyle's law. This is an indirect relationship. Why? Because when one goes up, the other goes down. So I just showed this as a picture once. If you have these molecules like this, and all of a sudden you put them in half the space, they're going to have double the collisions, right? Because it's going to bounce off the walls twice as much. Collisions are pressure. So the pressure has to double. Pressure has to double. You could show it in an illustration of this, like say, according to this equation, the pressure would double, or you could say by cutting the volume in half, the pressure would result in doubling. But if you don't feel great about that, the equation kind of hammers that home. Okay, so, but you're right, good job. The pressure does double. And if you just said, I'll tell you now, if you just said it went up, you would have only gotten 1 point. Showing this equation, just so you understand this, actually showing and referring to Boyle's law in this, actually would have gotten the other point according to the AP scoring. So what this does is it shows that relationship. So it's not always fair. It's about showing the whole picture, though, showing the story. So you had to discuss this. If you didn't come up with Boyle's law, you would have had to at least talk about that in words, which I think is a lot harder to do than just writing an equation. Now, you don't just write this. This isn't the answer. You say that the volume, by cutting the volume in half, the pressure would double, which is illustrated in this relationship. That would be my answer. Okay. Speed of H2 molecules. Libby, what do we have?
I'll do the same because the temperature didn't change.
Yeah, it's unchanged. No temp change, right? And then I would say that speed is affected by temperature. You're like, oh, Ken, energy is affected by temperature. So is speed still. Speed definitely is. I mean, nothing else has been changed. Believe me, when you shrink the volume, it's not like these are moving faster. They're just colliding more often because, I mean, just think about it. If I had to run back and forth and keep hitting each side of the wall, and all of a sudden the wall gets shrunk in half, I can run in the same speed and I'm going to touch the walls twice as much. I don't have to run faster to do that. They don't speed up. So, okay. So I hope that just helps us, again, get our minds into that. I'd be studying that. I'd be studying that little half sheet with the, I think, 5 balloons on the top, kind of how we answered some of those. The last thing I'd like to do on a sheet of paper, wherever you have, I want to just end with a little extra story. I'm making this as simple as I possibly can for you in what you need to write. But I'm going to let you kind of do it with each other. I'm going to get you started, and then I'm going to back off. Okay, we're going to do 3 problems, but they're all linked on this one problem. So just understand you need a little bit of paper. But I have 17.2 grams of propane, which is in like your gas grill. It combusts. I have these conditions. What's the volume of CO2 created? So I want to talk about that. So I'm going to talk for about a minute more, and then I'm going to let you get into this without me. And then we'll come back. We're going to do 2 more little problems off of this situation. I want to make sure that you understand this, because this is where some more points are, like I can grade a little bit more specifically on some things. The minute it starts talking about one compound and it brings up another, 2 things need to come to mind. 1, stoichiometry. 2, I need a chemical equation. I need to know the story. So you should be able to do this. Actually, I'm going to let you see if you can get it first without me. Can you figure this out? You should be able to. If not, you're not connecting all the dots, and I'll help you with it. We did a lot of combustion last year, and a little bit this year too. stuck. My gosh, the fact that it says created, CO2 should be placed on the right. And this is probably on the left. I hope we came up with that. If not, if you're finishing up, sorry, I'm not trying to rush you, just want to make sure we have enough time to get here. Balance it out. So personally, I like to organize my information. If you don't need to do it, good for you. If you're not sure where to put variables like pressures and temperatures, you can just put them in the arrow too. Or you underline them in your problem, whatever. You want to make sure that you recognize what you have. So if I start this, I'm just taking an opportunity, your last one, to have a problem from scratch. So what I suggest, either do this on your own, if you want to work with someone else, kind of go in and out with them, or compare it at the end. I don't care how you want to approach this, but do what's best for you in giving this a shot. I want the final answer. I'm even going to erase this. I don't even know what you're doing. Oh, that really works. How much CO2 would I make? When we're done, one important thing for you is to check how you wrote all your stuff with how I wrote mine. Right? Are you writing all the numbers, all the labels, all the units? It's really important to keep things straight. I've already illustrated that once. Grant found my mistake because I wasn't labeling it right. It was a big deal. I would have gotten that wrong. I'm going to start mine. I don't want you to look up until you're done, okay, please. But I want to just start mine so then you have that. Please don't look. We're done. Take a look, Kurt. He is the room right before the math pot on the left side.
Oh, okay, thank you.
Yep. You should, as you're doing this, if you're not done, don't look, but you should envision the flow chart. So, okay, what do I have? I start with grams. Oh, I want volume of the other. So I'm envisioning grams and moles, down the volume. Oh, I'm not at STP. So I go as far as I can, and then what do we learn? We need to use an ideal gas law. The big thing, I'm gonna pull out a little trick here. Heads up, check this out. The big trick, wait, that's not Boom, that, right there. Make sure that when we're labeling our volume, did you label it correctly? Or, with a magic pen, I could do this as well. Oh, there, that's what so, can I make it bigger? Okay. So everything needs to be labeled the way that I have it. And then if you don't want to put the NRT or P, that is fine, but we made it as far as we could on the flow chart. We tried to get down here, right? But then we have to jump over and do our NRT over P. In contrast, we're not reinventing the wheel here. If you have questions, please let me know. But I want to do, oops. That disappears. Okay. Hey, it disappeared. Okay. Another problem with the same situation, so you don't have to write an equation. So we're going to do one more at least, okay? Now I have 190 milliliters of oxygen, so same equation, okay? So same stuff, same pressure, same temperature. How many grams of H2 are produced? H2O, sorry. So now, imagine the flow chart again. I guess what I'm asking is, can I start with a T-chart immediately here? Can I start with my T-chart? I have volume of my gas, I want grams of my water. Can I start, can I get into a T-chart immediately? The answer is no, because you should envision, hey, what is this? Oh, all right, so Mr. Navarro, I'll get it to you. All right, thank you. So, what needs to be done? Like when I'm looking at this, what needs to be done? Oops. Chris, what do I have to do? How? So I'm here right now. Okay. I'm here right now. I want to end here. Okay? Like that's where I am. How can I get up this line? I need 22.4 liters. When can I use 22.4 liters? When I'm at STP. Am I at STP? No. So what do I have to do? Remember, if you can't go down this line, what do you have to do? You have to take a detour. So, I'll get you started. Right? We don't do this one as much. That's why I'm wanting to make sure we do this one last time. I might have to start with an ideal gas law. So, execute it. I'm going to do a different one down here, and you can write it down if you want or not, but this is a different one. If this one is at STP. This is what you would have done if it was at STP, but work on the green one. green is one you're working on. The red is if it was at STP. I want you to see the difference between them. Obviously, the red one's easier. And why I say easier is there's just less work. So, wrong term, but less effort involved in it. But it is really important to see, this is our second time through this stuff. We technically did all this last year, but it definitely doesn't hold. You gotta practice it, I get it. But you have to be able to have this vision. The only way I can stay on it is on the bottom part, volume. It's the only issue, volume. Grams and particles and all that's clean. But volume, I cannot be on the flow chart if I'm not at STP. So I gotta go through it using the ideal gas law. So hopefully you're labeling things this way. I like to, for surely, if I'm not solving for P or V, I like to write it out. I like to see where everything's at, personally, because I can see myself making a mistake there. We use the KPA. I didn't address this before, so I'm just going to use the 8.314. I don't want to convert that. Put it all in, and then just a smart move, guys. Instead of rewriting out, if you solve for moles, why rewrite it and then do a T-chart? Just grab that T-chart right away. If you start far enough to the left, if you don't do that, that's fine, but you can totally just grab that and just go. So take that answer and make that part of your T-chart. And then this was if it was at STP. Why can I do that? Is because now I can go straight up this line using 22.4. Could I have done this method here? I could totally do that. What would I just plug in? My T and my P be 273 and 1. I get the moles and I go. I get the same answer. There's just the relationship of 1 mole at STP comes out to be 22.4. So it just fits in the T-chart instead. Okay? You don't need to memorize 22.4, although our test is not in this room. It's always in that box. That's actually how big 22.4 liters are below my STP camel hat, which I actually have the STP more for stone temple pilots than anything else. Just a nice coincidence of STP for science. So, there you go. Tomorrow, lab, equations 4, which I've done quite a bit of it with you, and your book work, which was 8 problems that was actually completed over a week ago, technically. I know, that's a funny joke.